Welcome everybody to the first webinar for OpenCall 2 and OpenCall 3.1. Thank you for joining. We are very glad to see that there is a lot of people here today, and we know you have a lot of questions, so we'll try to solve them today. Here in the screen, I have shared the agenda for today. So real quick, just to go over it so you know what to expect today. Our coordinator, Anastasia, will be doing a short introduction about the project and the context of it, as we always do. Then we will have information from me. I'm Álvaro Parejo from F-Success, the partner in the consortium that leads the open calls. We will be talking about open calls, overall objectives, funds, requirements, eligibility, or overall. Then we will get more technical overview about the platform and the pilots. This is something that you are very interested in. We know about it, so we have included more time on it than last time. Our colleagues from Subsea and other partners like CUD, European Dynamics, and Fireware will be talking about the technical aspects of the project. And then at the very end, we will have like a very big Q&A. So all the people that are here today have the chance to open their mics or write in the chat about technical aspects or any doubts that you have. We will try to solve them the best that we can. Then we will talk more about what is coming up on the project, and that will be it. This is the agenda for today. So then, sorry, Anastasia, you can start with your presentation and introduction, as we said before.
Okay, hello everyone, and thank you for joining. I want to say, just inform you that this is our second webinar, and we have already run one webinar that has been registered in our website, and maybe you can also have a look at it because it has some complementary information. So with this one, we try to go a bit deeper in the technology part and in the pilot description so that you can understand how better to fit your ideas in our requirements. So it's really recommended to have a look at the previous one. So I give a very short overview for the ones that haven't heard about us and our objectives, and maybe again this is more complementary in the other webinar. So Circuloos project aims to empower small manufacturing companies to give them digital tools and adopt innovative practices in order to enter in the circularity domain. We are doing this by following these main strategies. So we are trying to set up supply chains that are focusing on the circular, closing the loop or the circular manufacturing. And we do this by helping to set them up, orchestrate and optimize them so that specific criteria are optimized. This is done also by seamless integration of production monitoring systems so that we can gather data and share among the supply chain partners so that these criteria can be calculated to select the best supply chains for our purposes. And this includes the calculation of product sustainability and circularity indices. So our main objectives are 5. The first one is the supply chain platform that includes a secure data sharing environment where the partners can share their information about products and processes so that they can be part in the supply chains for circularity. In the second objective, we create tools and methodologies to evaluate the life cycle assessment across the supply chain, moving from a single player and a single product manufacturer to one that is produced across the supply chain with various players that need to cooperate to calculate the right indices and improve the product, extend the product life cycle. We support this data exchange with the trust framework that we will explain. And we are funding with about 3.6 million new ideas that are adopting our practices and our tools and demonstrate new products and new concepts for circularity. So these are overall 3 calls. 2 are open today, the open call 2 and open call 3.1, and another one will come later on at the end of towards the end of the project, where we have more supply chains available to enhance the scale. This is supported by our RAMP marketplace, which is becoming a hub for circularity. So partners are registered there and they integrate their data and their processes and adopt the tools to be able to support these objectives. So I leave the floor now to Alvaro to present in more detail the open call specifications.
Perfect. Thank you. Thank you,
Maybe
Anastasia.
meanwhile we can say that you can ask questions on the chat. We'll try to
Yes.
answer them, and at the end of the meeting we will go through all the questions that are remain unanswered. Then you can also raise your question even at the later stage.
Perfect. It seems, I don't know why, like I cannot share the Microsoft window, but I'll just share my screen, my entire screen, either way. I don't know why it doesn't work now, but it's okay. Can you see my presentation? Yes, right? You can, right?
Yes.
Okay, perfect. Okay, so as I said before, Alvaro from F-Success here. My presentation is about the overall information about open calls. So as you know, Circuloos has several open calls, and we are doing a lot of activities. We are doing matchmaking workshops and webinars like this one. We are doing funding, and we have different activities. So we have 3 open calls. One of them is already passed, and now we have open call 2 and open call 3.1, which is the ones that we are focusing right now, as you might know. Open call 3 is divided in 2 steps, but today we are focusing on the first step, which is 3.1. As Anastasia said, 3.2 will come later next year at the end of the project. This is the overall timeline. So we launch on April, and we are doing the dissemination works. So right now we are on the second webinar that is today to solve all your doubts and give you more information. Important dates are the deadlines for both of them. So Open Call 2 is closing at the end of this month on the 28th of May, and Open Call 3 will be extended until the end of June to give you more time to be able to apply. What we are looking for in these open calls, we are looking to create manufacturing supply chains that aims to develop circular products and services. This means that these supply chains will be able to adopt any of the air strategies, which are the ones that you see here, that are recycling, remanufacturing, repairing, and refurbishing. For on Open Call 2, the first one, you have to apply as a consortium between a minimum of 2 entities and a maximum of 4. We are providing funds to each entity of this consortium up to 60K per partner, meaning that this whole project, if you have 4 entities in the consortium, will be able to get 240K per consortium. And we are aiming to fund at least 60 consortia or where the budget exhausts. The funds, of course, will be distributed upon successful delivery of technical and business reports. And for Open Call 2, the monitoring process, the duration is 12 months, starting on September. So for this consortia, they should develop circular solutions that extend product life cycles by implementing the R strategies that we just talked, integrate digital tools from the Circuloos project that we are developing, also develop the new digital IT robotic tools if necessary to support the new supply chain, validate the improvement in terms of life as cycle assessment, and develop novel products and business models. You can find more on our section 4 of the Guide of Applicants for both Guide of Applicants. This is just a short summary just for you to know what to expect and what we are demanding. But I have a short list here that we just put together just to give you a quick look. But again, it would be better if you go to the guidelines, which you will be finding the whole details and aspects of each one. So key activities for Open Code 2. Define novel value change, design scenario, use case, and adopt an error strategy. Re-engineer processes, document BPN, calibrate LCM measurements, use Circuloos tools, as we already talked, demonstrate execution, and measure impact. Here we have an example, a detailed example, practical, that so you can understand. I will give floor to Anastasia, our coordinator, right now, so she can explain better. But this is a use case, so you can look more fully what an example of what we are looking for.
Yes, so here we try to present a use case, an example, what we find in the literature. So we present here 3R strategies, so reuse, recycle, and recover. Each one of them going up, let's say, on this opposite pyramid, it shows that more value is created by putting less material in the trash, in the rubbish, let's say, so that the more we go up, the more bigger part of the products or materials are reused. So in this example, we have a carpet that in the first case, the reuse is completely processed to be reused as a whole. In the recycle, we keep it, we split it in parts, and the parts are processed to design a new carpet. We'll see this in the next example. And in the last one, the carpet is recovered in the original materials like yarns, energy, and all this, and they are it is used in this by reusing these parts, recovering, let's say, the original materials. You can go back next, please, Alvar. So here you can see this is the details of the example. It's called re-entry. I think in the next slide we present also the link and the detail of this use case. So in the reuse one, the carpet as a whole product, is cleaned and repaired and is donated to charity. So as a whole. In the second, next slide, please. In the second case, the recycle, the carpet is split in pieces, and these pieces are given to designers and manufacturers that combine pieces of carpets in a very novel ways and create very impressive designs that are giving new value, new life to parts, because the other parts are destroyed and they are not reusable. So you see here on the corner the link and to check the use case. And the next one is the recovering of the original materials like yarns, that energy that are given to to other useful parties that want to use it. So for us, this could be a good example showing various value chains that are formed in a way to reduce the amount of product that is put at the end of life and giving new life with new ways of working, let's say, like new designs, new processing of the old wood, carpets, or new cutting and fixing of the carpets. Thank you, Alvar.
Thank you, Anastasia, for the full details of these cases. Nice. So that was OpenCall 2. Now we are entering on OpenCall 3.1. So this one is different. Is enabled for single entities instead of consortia, so you can apply as a single entity. And the objective of this open call is to enable extension of pilots and newly established value chains. So we are aiming to add one new MSME per pilot to benefit and contribute to this value chain, and extending and scaling it up, improving the sustainability performance of the pilots. Again, we build on the existing pilots, and also for the second part of OpenCall 3 that will be next year, it will be extending the pilots of OpenCall 2. Here again, the funding is for 60K per new entity at a 60% funding rate for private organization, 100 for researchers. Here is a summary of the activities of the entities that will join the pilots. So it will be to introduce the new air strategies, so expanding recovery and reuse within the pilots, enhance existing processes like improving sorting, remanufacturing, or recycling, and then validate and refine our digital tools, like using real-world data to optimize lifecycle tracking and sustainability assessment. So again, I put the key activities here, so you can have a quick look of them. But it would be, if you want more detail about them, it would be better for you to just go to the webpage and download the guidelines for this open call too. So again, the key activities are collaborate with the pilot stakeholders, extend Circuloos sourcing, enhance pilot capabilities, validate and refine Circuloos tools, develop scalable Circuloos methods, capture real-world data, and track environmental impact. For OpenCode 2 and OpenCode 3, again, we want to make clear that the funding rate for every project is 60% of the eligibility cost for profit-making entities, but 100% for nonprofit or academic organization. You have to be really aware that once you receive the funding for OpenCode 2 or 3, you will must to contribute a 40% of your own funds into the project. That could be covered by other eligibility costs like personnel or travels, etc. So where can I apply? The application will be available directly on the App Success pages. You will find the links and the redirect links on the Circuloos webpage. You will have two of them. So if you want to apply to OpenCall 2, you will have a dedicated page and App Success, and for 3.1, the same thing. You will have to download the documents, the application from in the website, although you can also find the links on the application form on the success page, fill it up and submit it through the success page. So I'm going to put here real quick the links in case you have missed it or you didn't visit the webpage. They're really easy to find on the tab for open calls in the Circuloos webpage. But here you have the QR codes in case you are curious and you want to check them out right now. Again, you are able to find these links on the Circuloos webpage. So here is the complete process of how the open code looks. So you will download the open code form on the website. it's an annex. For OpenCall 2, it's Annex 2. For OpenCall 3, it's Annex 3. You will submit it through the form of a success. And if you are able to be eligible on all the first terms, you will pass to the evaluation. If not, everyone that gets rejected will get a rejection letter with the motives. But once you go through evaluation, we will have three experts evaluating your proposals to make sure that you are aligned with the project in the most fairest and transparent way. And then after the consensus meeting, if you are pre-selected, you will be able to start working with the pilots in case of OpenCode 3, or your own supply chain and your consortium in case of OpenCode 2. The time here is that evaluation is happening in June. We will see it later. And then the contracting and assignment of documents will happen between July and August. So you can start your monitoring phase by September. So for OpenCall 2, this monitoring phase will last 12 months from September this year until September next year. For OpenCode 3, it will be 9 months from September to February, right? Then this monitoring phase has some key activities that we already went through them, and you will have mentoring and support from a Circuloos team to develop the tools and improve your supply chains. But also you will have to submit some deliverables that we will ask you in terms of business and other technical aspects. So the evaluation, to be more concrete, as I said, we will be evaluating a panel of evaluators composed by 2 external experts and 1 internal evaluator coming from Circuloos partner on the technical side. The evaluators will be selected relating to their expertise in the circular economy, manufacturing, and related topics that will make the evaluation process fair. In terms of scoring, we have 3 different criterion here that are scored from 0 to 5, and each proposal will be able to get a max total score of 20 points. So here are the criteria that are divided in 3: in excellence, impact, and implementation. So for excellence, we are looking for clarity of objectives, novelty, technical approach, and other aspects. For impact, we are looking for the circular economy contribution, which is very important for this project. The target group relevance, long-term sustainability, and quantified impact. And the last one, implementation, we are looking for work plan feasibility, more in terms of coordination, experience of the team, and so on. So for each proposal to be selected, at least to pass, they have to pass a bare minimum, which is a score of 10 to 20. So we can guarantee the quality of each proposal that wants to join the project. And then after that, we will select the best proposals about the available budget that we have. Here, the timeline, as I talked last time, my previous slide, is that evaluation. Application is happening now, but evaluation will happen on June, the whole month of June, and then the selected applicants will start working on the signing of contract and other documents that will be able to join the project. So finally, as we said, in Circuloos, we have different tools that will have to implemented and used by applicants that want to work with us on the Circuloos project. So here I have the table, because this is like a doubt a lot of applicants had about the tools. So here you can see a full list of what we require as mandatory tools to use, and then the optional tools for each OpenCall. So as you can see, OpenCall 2 has half tools that are mandatory and optional. The most important ones, of course, is RAMP, Circuloos data platform and life cycle assessment, which is mandatory on the 2 open calls. But open call 3, as you can see, has more mandatory tools. It has every of them, but not supply chains optimization, which be optional. So please make sure, again, to revise very well the guidelines and to make sure that you are including these mandatory tools onto your proposal. This is a very quick overview of the tools, but the next presentation will get a deep dive into the tools. So here, just as a reminder, this is my last slide. As a reminder of our open calls, what we have right now. So we have 2 open calls, open call 2, open call 3.1 open now. We are giving 60K per partner, 200K per consortium in case of open call 2, and just 60K per new entity. Open call 2 is for consortiums, and open call 3.1 is for single entities. And everything is a 60% of eligible cost. So you can now apply, you can use the links, and thank you very much for your time. And we are going right now to the tools presentation. How can I escape this here? Okay. So right now, if Elia from Subsea is around here, maybe you can start sharing. There you go. Perfect. Thank you.
Hello, everyone. Good morning. Okay. Good morning, everyone. Before going to the tools, I'm going to present the pilot's overview within the research project Circuloos. I'm Dr. Elia Ruiz from the University of Applied Science and Art of Southern Switzerland, where I am doing, holding a position of research scientist. And I would like to introduce you a little bit about the pilot's overview in the Circuloos research project. So we're going to start with an introduction of how is the approach of the Circuloos project. It's about collaborating for a sustainable future. It's a collaborative approach among companies to create a more sustainable and circular products. The goals here for all the pilots are working together to achieve a sustainability that goes beyond individual efforts. So I saw many questions right now in the chat about if it's about changing operation, if it's about value chain. Here, the most important goal is working together without necessarily change anything in the company, but trying to improve sustainability from collaboration. The content of this presentation is going to be as follows. First of all, I'm going to present the value proposition for each of the pilots, how the pilot creation is performed within the Circuloos project, and how the sustainability practices are measured using advanced tools that are proposed by the Circuloos project. In the end, I'm going to present the Circuloos pilots that are running right now in the Circuloos research project. So concerning the value proposition in terms of the circular chain, its Circuloos pilot is more than an isolated initiative, is more a strategic link in a broader circular value chain. So from initial execution to the adoption of circular practices, every pilot can contribute to a bigger, scalable and systematic transformation toward more sustainable production and contributing to a circular economy. How it works? So from pilot execution, the practical implementation of collaborative sustainability effort is performed through the study of individual goals. So then the integration into the circular chain. So we have to ensure that each company connects with each other to form a cohesive systems in order to attain global aims. Let's say integration of the goals to achieve a just single goal that could contribute in the more sustainable production for everyone. Then the implementation of the circular practices will be evaluated through advanced tools, and the real-world adoption of more sustainable methods could be guided by shared insights and tools. The value proposition in terms of sustainability and circularity focus into the pilots used to be there are practices that have been presented right now. So reduction of resource use, avoiding waste, reusing material across industries. So in the end, most of the R practices are the goals of all of the pilots. So ideally, we have to go from local processes, so the isolated processes, into a value chain system. What is a value chain system? A consortium of local processes. Here you have an example in the figure of a single production system producing just one product, but we can also talk about multi-product production system where we go through different local processes to a single value chain system producing exactly the same products. The product is a service to the community, so we can go from 3 products to just one process processing 3 products and providing 3 services to the community. Exactly the same, but reducing the processes. What is the value proposition for the companies in the Circuloos project? Tangible benefits in circular innovation to the companies integrating the system within a pilot. So, accelerated innovation through collaboration and shared pilot results, reduce environmental footprint or other environmental indicators or other social economic indicators via smarter data-driven decisions, competitive advantage by aligning with circular economy demands, and access, for sure, access to best or better practices and tools for measuring and improving sustainability and circular in the circular economy context. How is the impact on how we measure the impact of pilots on sustainability or in circularity? We develop project KPIs pilot specific, which means we have to investigate the pilot, we have to define and find the key points of each pilot, and we will adapt the KPIs. In most of the cases, for sure, it's about economy and environmental issues. So a sustainability increase, which is, why not, is like the goal of all these indicators together. CO2 emission reduction, so environmental indicators as a priority. Material cost reduction coming from avoiding the use of raw materials. Reduction in virgin of raw materials, which involves a reduction in cost. Energy consumption reduction coming from the value chain integration. So here you have some examples that we have already defined for our pilots. So at least 25% in sustainability increase. How? Through environmental indicators, through economic indicators. The CO2 emission reduction, this is the climate change indicator from a life cycle assessment. The material cost reduction and the reduction in virgin raw material 100%. So we are really targeting to not use any single raw material. This is quite difficult, but could be for some processes. And the energy consumption reduction. Sometimes we can even have more energy consumption, but we can have benefits from the value chain integration. So let's say that the KPIs will be defined for each pilot particularly after a specific detail analysis. Now let's move to the pilot creation process, how we create a pilot within the projects, within the Circuloos research projects. We transit from local to value chain system. What does it mean? The initial state is what we have called local. Pilots begin with isolated processes focused on individual sustainability goals. It could be, like we have said before, there are strategies like reducing waste, improve efficiency, but why not expansion? We have, for instance, one company within a pilot that they are recyclers. It's a recycling company, but they look for expansion. So they also come to our pilot, and it matches with other companies that they are not really in recycling a lot, and then we have an integrated process where we have recycling of the waste. So it could be also becoming more circular, but it could be also expansion. For sure, there are independent operations. Companies work on improving their own production without collaboration or integrating with other players in the value chain. So we are starting with local processes, and then the transition to integration. As collaboration increases, companies share resources, knowledge, technologies, creating synergies that improve circularity. Circular practices are extended from individual operations to the entire value chain, and we look at the geographical location as a priority. Short circuits, we are looking for companies that are not very, the distance are not very high, because there is no need to match a company from China with something in Europe. I mean, it's not worthy, right? So short circuits are also prioritized in the transition to integration. In the final stage, the integrated circular manufacturing, we address the full integration of circular processes across the supply chain, optimizing material flows, reducing waste, and reusing resources. Companies collaborate closely to achieve sustainability goals from production to disposal, creating a closed-loop system. We have to really identify the boundaries. We don't need to go from production to disposal. We can only go from production to the gate, so cradle to gate instead of cradle to grave. But this is something that we are also going to define with you and with your interest. Once we have the pilot created, we need to evaluate in order to provide decision making, right? So there are many important questions that has to be addressed, that has to be solved before changing something in our companies or in our system of companies. So a very important question is the environmental impact of the product significantly reduced? But we don't have to forget that we are talking about companies. So is the new system economically feasible, scalable at the long term? And integrating these questions, is the evolution from local processes to value chain systems enhancing the overall sustainability of the product's life cycle? This question has to be addressed, has to be evaluated, and have to be solved. And how? We are going to do it through the advanced tools that are provided by the Circuloos research projects. RAMP, Greta, the optimization tools or other digital twin, all the tools are required to give answers to these questions. And these questions will guide us for decision making, or will guide you decision making. Just to conclude, I'm going to present the Circuloos pilots that are running right now in our research projects. So far, we are having 3 pilots. The first here is the wood pilot based in the Netherlands. The product that we are evaluating is a wood-based building panel for construction within the wood furniture manufacturing industry. And here the process is about circular processes focusing on using reclaiming wood from trees of the city of Rotterdam in the production of wooden products. In this pilot, we have 3 companies involved. Then we have the leather pilot based in Hungary, where here we are talking about 2 types of products. As I said before, could be also multi-product system. So in this case, we have, for instance, a bag and a small accessories like the wallet here. These products are in the leather fashion industry, and the process is about implementing sustainable practices in leather production by reducing waste or avoiding waste and exploring opportunities for recycling and repurposing leftovers. Here, we have already 2 companies involved. Finally, in the plastic pilot, it's a pilot based in Spain. And we are evaluating a plastic-based household product. Here is a container for the washing machine. Is in the plastic manufacturing industry. And here the process is about developing circular solutions for plastic waste, in a sense that they can reuse their waste for avoiding more raw materials. Here we have 3 companies involved, and one is actually technology. There is a technology company helping in the recycling part. So if you have, finally, before question, I'm going to finish with a concluding remark. For doing a recap, I have to say that through data-driven insights and collaboration of cross-company collaboration, we are able to achieve significant environmental, economic, and social benefits. So in other words, sustainability benefits, moving us closer to a fully circular economy from a linear economy. So thank you very much. Now we can talk about the tools, and then we will proceed to the question and answer, if you agree, right? Thank you so much.
So now we will have Francisco joining with the presentation from the overview of the technical approach.
Yes, hello.
Perfect.
I'm going to share the screen. Screen number 2, share. And now you should see the opening slide in full screen, right?
Yes.
Okay, great. Thank you. Well, my role is to, let's say, present an introduction to the architecture that is enabling all this type of collaborations and interactions from the digital perspective, let's say. So I will start with a recap on what I presented in the first webinar. And to me, the powerful idea and one of the core messages we delivered when preparing the project was that we are aligned with the overall approach typically used in ICT services. We do consider products as resources that are undergoing multiple transformations, and then circular manufacturing services are those processes which really execute and implement those transformations. The product has a state that is transformed right after the application of manufacturing services. And then we consider manufacturers or endpoints, participants in the manufacturing supply chain, as service provider. which are own the processes that are executing the transformation. This was the core message we delivered in the first webinar. And then we introduced a bit in our platform how we are dealing with the abstraction of the different participants, of their processes, of the products, of the technologies they do have. And for us, there is this kind of formal modeling of manufacturer processes. And we rely on a standard for those who are already familiar with some of these technologies. VPN is our abstraction to do so. And then we entered a bit more in the layered architecture, where we do have a layer for data acquisition, then some kind of processing data, and centralized infrastructure, which is able to pivot the data to the tools that will be presented right after me. But let's say you could have the details in this first webinar on what I presented in that time. The overall vision, and I think we could discuss for long around this picture we have developed for the entire vision, is that one of the participants in the supply chain, a manufacturer, a producer, some provider of services for logistics, has its own shop floor with a number of machines and personnel interacting with the processes. And the idea is that somehow the digital transformation of real-world activities can enable this participant to generate data that allows the company to collaborate outside the boundaries of their processes. And for that, we are contributing tools. This is the number 3. We are giving technologies for connecting your machinery, for harmonizing the data that your machines are able to share. With that ability to digitize and to serve data, the idea is that this number 1, the supply chain platform that Anastasia was introducing at the very first presentation, and the different tools that you will see right after my pitch, enable this virtual environment, this data layer, where not only your data, but the data from other manufacturers, from other service providers can be somehow harmonized, put at the very center, and accelerate the actual collaboration we need. In here, you have some examples of what it is, what are the main concepts that are behind our use cases. In particular, handling the offering, the ordering, the demand, even being able to forecast some kind of behavior based on the indicators that we do have in there are cases for this data layer. But we do also have some kind of interactions that aim to make more operative the collaboration, such as how to deal with the handling of the different offerings, or for closing an operation, for transferring some leftovers from there, from here to there, how to display my offering so that others can be aware of it. And then we could go as much as detailed as necessary if we do have an actual business case in our experiment to elaborate on how this data layer can be an accelerator of the transformation. So more or less, this is the idea. You have your local environment, you are executing a digital transformation step, you can do even optimization on site, and then somehow you identify a series of data that you can share in the common data layer and accelerates your potential to collaborate with others. For that, Circuloos is bringing your supply chain platform and some tools that will allow you not to start from scratch, but to exploit an existing infrastructure and some utilities. This is the overall idea. And with this overall idea, I am now entering on some more detailed technical slides. which only aim to serve as, let's say, inspiration or guidance to those technical profiles now today in the webinars, or for those who are not from a technical background, at least we are giving them the resources for activating the discussion with the technical departments. So this slide aims to convey one message. Is okay, Circuloos is telling me that sharing data is key to the entire hypothesis we are considering in the project, and my experiment should contribute to that. But how will it work in practice for my experiment? Let's say the simplest, the helicopter view for this course of action is that, well, with this supply chain platform, your organization will be given access to the overall platform interface with a username and password credential approach. Then, upon request, this data platform will grant token that your systems could use to send data to the shared data layer. And then there will be some kind of pre-processing step you will need to implement, and this to prepare your shop floor data, generate the necessary aggregates, and for that it is that JSON LD format is kind of our core and vast term in there. We need you to work on structuring the data you will share, and we will work together in creating a data model specification that then will accelerate the interaction across participants and environments. Having that step 2 ready, step 3 will be as simple as sending data using the API endpoint of a central platform and posting your data in there. This will be more or less the story. Having said that, for those who will address the design of or pre-design of the solutions for the experiment, some concepts are relevant. We are aligning with the fiber technology and with fiber-related standards to perform data acquisition and to send data to the platform. The concept of fiber agent is relevant, and you already have agents off the shelf to be used. There are even some custom components that have been developed inside Circuloos to give proper examples to the experiments. And then the third point is that this data sharing we are aiming to with Circuloos is not about sharing all my data or nothing. I mean, experiments can keep sensitive data in their system. Circuloos is not aiming at accessing to them at all. Expected data processing will not be intrusive to those processes that are already there. Your legacy system does not need to change. It's just about implementing a layer to serve the data that is of interest to you in the shared data layer. And then only a portion of the process data is selected for sharing. For instance, convenient outputs of a particular production processes, which are relevant to offer leftovers as a product. This could be perhaps a story for your experiment. Then I am giving in here some resources for documentation for those architects or technical designers to get familiar with. We have the Circuloos data platform. By the way, I need to add the explicit link in here, which is missing. Then a demonstrator with an example in a shop floor, and then generic documentation around the fiber technologies, the Smart Data Models program for data model templates, and what is it that standard we are building on. Depending on the level of interest you have, I would say top level, higher level is the Circuloos data platform documentation. If you go deeper and deeper in the stack, then perhaps at some point you are interested in understanding the standard itself. And I think that was my last slide. Yes, and I can just leave the floor to the next speaker.
Thank you very much, Francisco, for the detailed overview. Right now, we're getting back to Elia from Subsea. so she can present the sustainability, the first tool, Greta.
Yeah, thank you. Okay, so hello again, everyone. I'm just reading the messages in the chat, and after my presentation, I'm going to address all of them. I was just trying to follow all of them, and please, after my presentation, you will get the answers. So now I'm going to present Greta, the sustainability tool, and maybe it will clarify also your questions. So as I said before, I am a research scientist at the University of Applied Science and Art of Southern Switzerland, and we have developed a sustainability tool that you are. I saw already a few questions about if this tool is open source or not, and it's true that it's not open source. But is based on open source tools. So let's say this sustainability tool is going to be included in the architecture of the advanced tool in the Circuloos project. And that is why we have to use it as part of the evaluation processes of the pilot. So it's like more than a problem for you, I think it's a solution. Well, it's a solution in the sense that all the architecture is going to connect data with the evaluation instead of you taking the data from RAMP and then go to your own open LCA or CIMA Pro. So it's kind, let's say, of a platform that will help you actually to manage your data, the data of all the companies, because in the end we are looking for pilots, so it's a system of different multi companies. So actually Greta is going to help you to manage all this data. So that is why probably you don't see really well the difference between other sustainability tools and Greta, but it's basically because it's going to be adapted to your needs. So sorry for this part, but this was more basically was said actually for people who were asking a little bit in the chat. But for the rest, I'm going to start with introducing a little bit more about the concept of sustainability, because it's something that is really familiar to everyone right now, but maybe we are not all in the same point of what we are looking for. So sustainability, as an introduction, is about meeting present needs without depleting resources or causing problems to future generations and the environment and the planet and our community, right? So that is why we don't have to forget that sustainability, we are not just talking about green things or environmental stewardship, but we are also talking about social equity and economic growth. So we have to be able to manage the resources, the natural resources, in a responsible way, ensuring fair access and opportunities for everyone in our community, and for sure promoting long-term inclusive development, economic development, right? So it's about these three things integrated in just one single goal, right? What does Circuloos help with? It's about enhancing product sustainability by fostering collaboration between companies in the context of the circular economy, going from linear economy to circular economy, but in a sustainable way, because it's not always in the same sense. So we can go to a circular economy and not being sustainable at all, or be only profiting in economy, but not in environmental. So trying to match these three pillars in a circular economy context. And really, so these are the strategies that we have already talked about. It's about reducing waste, optimizing supply chain management, reducing material resource use, trying to avoid technology that are not helping in our environment. So all these things are going to be considered in the sustainability, in the Circuloos pilots. And how the sustainability is evaluated in Circuloos. So as I said before, it's about sustainability assessment using the life cycle assessment methodology, LCA. We have already talked about LCA, but I'm not sure if you all know about this methodology. This methodology, just a very brief explanation, is about measuring environmental impacts of products and processes. So LCA, we are talking about environment. The social and economic growth are other indicators that we can also discuss, and we are also going to take into account in our tool. But we are talking right now in Greta about LCA, so environmental indicators, environmental reduction. The Greta tool, developed by us, by SUBSI, applies this methodology to support decisions based on real data. Then, if there are others, if we need to really go into social indicators, economic indicators, we can also consider in the Greta tool. But what we are going to optimize, let's say, is about environmental indicators. How do we do it? We need to track, as you see in the figure process here, tracking material and energy use in order to build the life cycle inventory. So we need to quantify all the energy and mass flows in our process. What is this process? Is this process your company, or is the integration of all the processes? Is depending on each case. Greta is able to calculate LCA of no matter with, we need just to define the limitations, but we can go from a single process to the whole system. And for sure, in the end, once it's optimized, we are going to evaluate the whole system. And we will go from cradle to gate so far, unless we find other pilots going from end of life or something. So far, we are basically stopping at the gate of the company, so in the production of products, so cradle to gate. But we can also use Greta for your own company, and then like this we can move later. I will explain this a little bit more in the next slide. So from the life cycle inventory, we go to the LCA here, the second figure you have here. So from the inventory, we go to the LCA, which is performed within the Greta tool, and then we will provide environmental indicators and the relevance at the global scale in the planetary boundaries. As I said before, Greta is a tool based on LCA for decision making. So we will guide decisions, the companies, using the LCA methodology, calculating environmental impact of products and supporting more sustainable practices. Here you have an example here at the bottom of the slide. You have an example of pilot system. What I called before value chain system, okay? So let's say here two companies are coming together to build a pilot. We have company A and company B providing data to the Circuloos data platform. Okay, so data from the companies, real data, is going to the data platform, and the data platform interchanges data with Greta, okay, in order to build the LCI, the lifecycle inventory. And Greta will use their own databases that are already included in Greta. Basically, EcoInvent is one of the most common database right now worldwide, but we can also have data created by us based on literature if the product is really new or something that is not in the EcoInvent database. So once we have the model inserted or uploaded in Greta through the Circuloos platform, the user from the pilots, so the pilot users, can interact directly on Greta, running their own assessments and even modifying some variables, like not all of them for sure, because we cannot change things that are already happening in the company, but we can change, for instance, distances between company A and B. So imagine that we can have one company that can move a little bit closer. So this distance can be changed in Greta directly. Like this, you will see, okay, if we reduce logistics, we can even have a very good target, good KPIs for our product, right? So we can use Greta for optimizing, along with the other tools for sure. And once we have Greta, once we have the final system, we can do the evaluation and we will return the results, and we can see the results in the Circuloos data platform. So we have to pass through Greta, and Greta will return the results into the Circuloos data platform. So it's not direct access to Greta. There is no need to go only to Greta, but Greta is integrated in the Circuloos platform, even though the calculations are done outside. I mean, in the Greta itself. Just to recap, that Greta is a tool for analyzing a single value chain. As I said before, it's important to define the system boundaries. So from raw material extraction to end of life. If we want to stop at the production gate, we can stop at the production gate, but the limitations are done by the user or by the experts that are helping that are helping the pilots. But we can also go from a single company to different value chains. So the system integrating different companies. It's really important to recap, to recall that we are able to define the system boundaries in Greta, in our study. The value of Greta, just for concluding, is Greta is able to perform comparative assessments, sustainability assessments, of systems to identify the most sustainable option. And we also allow, Greta allows end users to run assessment directly, to modify also variables, and for sure support informed decision-making based on sustainability criteria. Then I will try to answer all the questions in the chat. Thank you very much.
Thank you very much, Elia, for this full presentation and details about the Greta. Now we have from European Dynamics, we have Boclis. He's going to talk about RAMP.
Yes.
So if you, perfect. Hi.
Hello, I'm Panos Buklis from European Dynamics, and we'll give you a brief overview about RAMP. So RAMP in general is a holistic platform that provides online features in the terms of marketplace, but it also connects to with the IoT platform and brings the production line to the web online, and has tools to help digitize the production. I will not go into what exactly it is and what all the features are there, but you can refer to the previous webinar on some information introductory about RAMP. So what I will focus more today is on the main tasks that you will have to do during the experiments with RAMP. So you will have to create an organization profile. You will need to add some general information about the material and the waste that is produced or consumed. You will need to connect the IoT platform, the so-called data platform mentioned previously. You will need to monitor and verify the data that is fed to the IoT platform and from there to RAMP. You will need to perform material transactions like buy and sell material across the supply chain, and you will set up all the different tools that you decide to use on the experiment on the so-called app hub on RAMP. And I will go you through this one by one. So creating an organization profile, it could be the case that many of you have already done that during the matchmaking phase. Okay, it is quite straightforward. You need to register and create a profile for your organization. You can also add different members there. It is just a guide. It guides you itself online, so I will not go through that. So what you will need to do specifically for the experiment, a first step is to add general information about the material and waste or leftovers that are produced or consumed in the factory. The idea here is that having specifically this information can facilitate the matchmaking with other organizations that either want to buy the material that you have as a waste or leftovers, and similarly you yourself can find can be match made with other companies, other organizations that sell the material you need. I will jump to the online on ramp, just to show you how it will look like. So you will have a pretty straightforward form like this, where you will define what is your factory, and you will choose the relevant materials that are that you use as input in the production, and also as an output. You will also specify some location information to facilitate again match making. So this is general information about the material that is produced and consumed in the factory. The next step is to connect with the data, the production line, with the IoT platform, which is directly integrated with within RAMP, and essentially whatever data goes to the IoT platform is available on RAM. So for example, an example like this is that, let's say that you could have a sensor or a device that somewhere in the line monitors when waste is generated during the production, or specific information about the waste that is generated. And this sensor is connected with the IoT platform and feeds it with the relevant data. The IoT platform on the next level, like I've said, is directly integrated with RAMP. So when you go in RAMP on your account, you will see it here. There is a supply chain, there is a sell material, and the idea is that this page shows the material that is available or on for sale gets this data directly from the production line and automatically. Also, this just to mention that this integration will be with the IoT platform, will be done with the support by the Circuloos consortium. And one more feature that you will use is what we call it App Hub. Again, this will be done supported ad hoc by the Circuloos partners. And in general, what this is it provides a common desktop-like environment that is accessible online, and gives you consolidates all the graphical front ends of the different tools that you will use during the experiment, regardless of where they are deployed. So you can have deployed different tools at different places, and we will bring them all together as in a user experience sense. We'll bring them all together in this environment, so they will be like applications of that are in one graphical interface. This is about RAMP. Like I said, there are many things there on RAM, many different features, but I just focused on the things that are related to the specific tasks for the experiments, and everything else that you would like to use will be available. I will actually now go straight forward to the next presentation. right, Alvaro?
Yes, directly since you again, digital, no, sorry, orchestrator, right?
Yes.
Perfect.
Okay, so the next presentation is about the process orchestrator. The ramp that I mentioned earlier was a mandatory tool that you will have to use in the experiment. And while the process orchestrator that we'll give an overview now is another tool that you may or may not use in the experiment. If you think it fits, it will be a plus. So again, you can refer to the previous webinar for the main features of this process orchestrator and what you can do with it. So about the actual tasks that you will have to do in the experiment. As a recap, this is a management system where you design the processes of the production and the supply chain, and it takes care of the execution and the decision making and providing interaction points with the devices, sensors, and the workers. So in the experiment, you will have to design the production and supply chain level processes, keeping in mind that the level that we need them, the level of detail that we need them, these processes in the experiments is by having the points where the human workers need to input something to the system, and also where the relevant data is generated. For example, where the waste is generated, and at that point we need, for example, to measure something. Also, these steps of the process will be connected. Need to be connected with the IoT platform, and from there, like I've said in the previous presentation, automatically connected with the ramp. And for this, of course, again, we will support you from the Circuloos side, and there are examples on how to do this, which is pretty straightforward. And of course, you have to what we call deploy the processes. So essentially, the next step of once we have designed them, to actually execute them, and make the user interface available on the App Hub. So the design of the processes will be done with an open source modeler. It will be made in a graphical notation of diagrams called the BPM business process management notation. So it is describing steps by the different steps with a diagram. At different points, you will have to define if we need input from the human workers, and for this, the tool itself provides a user interface with the open tasks and to do the actual input. I will show you that in a moment. You will need, like I've said, you will need some code to do some coding for connecting with the IoT platform. And once everything is deployed, you will be able to run it and have also a monitoring dashboard for this. Very quickly to show you how it looks like. This is the main cockpit where I can see the different processes that are available. We have created a very simple processes. There's just some adding some input, and you will see that this number here means that this is already running, so it is stuck on this step. It waits from input from a human. The tasks, I mentioned the interface about the open task, so this is again how it looks like. I see here there is an open task. And this is the form that I need to fill in as a feedback to the user. So it asks me for some ID, and there is some, I say that this is some kind of material, there is some waste, and asks me what is the weight of it. I will say that is 10. And now I'm doing it manually, but practically it can be a sensor that does all this measurement and feedback to the system. So let's say it is complete, and like I said, the idea is of the process was to record this. So you will see that it sends the relevant data to the data platform. So if I go to RAM and to the relevant place where this the data about the available material for sale is here, the supply chain. To sign in. You will see, I select the kind of material, you will see that there is, it is added here. And the idea is that others can say that this material is available for sale and can reach you to contact you to buy it and get it, or even set up a long-term relationship. Yes, that is about the orchestration. Thank you.
Perfect. Thank you, Panos. So that was Ramp and Orchestrator. Then the next tools are Digital Twin by Kat, if Anatoly is around
Hello.
here. Hi, hello.
Yes, so my name is Anatoly Diola. I'm a postdoctoral researcher at Cyprus University of Technology. The Cyprus University of Technology is responsible for two tools of the Circuloos platform, the supply chain digital twin and the supply chain optimization. So the supply chain digital twin, the SCDT in short, is a tool that simulates and visualizes supply chain arrangements and factory workflows to provide a visual representation of the factory inputs, outputs, and internal processes, as well as the interaction between the factories and the supply chain. The digital twin provides a detailed information about simulated entities of the factory, such as factory resources, products, status of internal processes, waste, buffer zones, CO2 emissions, or energy consumption, as well as the interaction between the factories, suppliers, and consumers in the supply chain. Also, the digital twin can be used to test alternative scenarios for for the circular intrafactory logistics and circular supply chain arrangements. So, using the BPMN file of the intrafactory logistics representation, we construct the factory model in the supply chain digital twin. This is an example of the SCDT implementation. The SCDT provides an abstract visualization of the intrafactory operations with respect to the input materials, output products, processes, and waste of scrap. The emphasis here is the potential of the factory to receive and produce products and scraps that can be utilized in the circular supply chain and not so much to capture the factory workflow in detail. For the implementation of the digital twin, the factory is considered as a system with inputs and outputs and some buffers and processes. So to build the factory model in the digital twin, the user needs to define the input resources of the factory, the products produced, the waste of scrap, and the internal processes along with their LCA costs. The inputs refer to the incoming materials and resources used by the processes, and the outputs refer to the products manufactured by the factory and the scrap produced from the processing. So the user can see the running information about the status of each entity of the factory by clicking on each of the visualized entities. And also, the user can change the icon and texture of each entity. And of course, he can add as many processes or buffers he prefers. A problem here might be to identify alternative processes or alternative workflow arrangements or storage capacities. So to solve this kind of problems and provide a solution with optimality characteristics with respect to LCA indicators, we have developed the supply chain optimization tool that we will present in a sequel. The data that should be defined by the user in order to implement the supply chain digital twin are the input resources or materials, the output products, the waste production, the internal processes, the suppliers, and the consumers. These data should be based on the current factory and supply chain arrangements. However, the user can provide, wherever is possible, alternative options or envisioned options based on real data to investigate alternative scenarios for circular intrafactory logistics and circular supply chain arrangements. And in addition to the intrafactory operation, the digital twin provides the supply chain representation of the interaction between the actors of the supply chain. So in this point, we need to identify the interconnections between the actors so as to define circular supply chains. To build the supply chain model in the digital twin, the user needs to define the suppliers per factory, the consumers, and the interconnections between the factory suppliers and consumers. So, for example, the products of a factory can be utilized as inputs of another factory, or the scraps produced by a factory can be utilized as input from another factory, so as to specify a circular supply chain. This is an example, as you can see in the slide, of representation of interaction of 5 factories in a supply chain. Similarly, with the case of intrafactory representation, in the supply chain representation, you can click on any of the processes, inputs and outputs of each of the factories to monitor the state of the processes of each factory. Another case here might be that some of the factories have similar inputs, outputs, and scraps. So the problem now is to identify which are the outputs of the factories that would be connected to which inputs of another factory, and to identify the circular supply chain with optimality characteristics based on the available LCA indicators, we have developed the supply chain optimization tool. So the supply chain optimization tool, the SCOPT, is a tool that proposes optimal or optionally suboptimal solutions to intrafactory logistics or the circular supply chain arrangements. It identifies effective intrafactory process arrangements and as well as supply chain arrangements with respect to LCA cost indicators, and the SCOPT provides recommendation also for the intrafactory and supply chain arrangements. And here you can see an example of intrafactory logistics and supply chain arrangement. So considering that we have the factory X that utilizes 2 different raw materials that pass through 3 different operations in order to produce 2 different final products and some scrap. The factory X interacts with the factory A, the factory B, and the factory D. So the raw materials are received from the factory A and factory B, and the final products are provided to the factory D. And also the scrap is provided to the factory B. The factory B recycles the scrap from the factory X and produces raw materials for the factory X and factory A. The raw materials are considered as input resources, the final products are considered as output products, and the scrap is the waste. Moreover, the suppliers and the consumers need to be specified for the factory X. And in this example, the suppliers of factory X are, as I said before, the factory A and factory B that provides raw material to the factory X, and the consumers of factory X are the factory B that receives the scrap, and the factory D that receives the final product. Additionally, we need the relevant cost indicators for each process, for example, CO2 emissions or energy consumption. And actually, what is the problem here? The factory X faces the problem of deciding from where to receive its input resources, what type of processes to implement, what to do with the waste products, and what is the size of buffers that they are going to be used for its input, its output, and its storage. Also, there are several options for the supply chain, as you can see. And in this case, the SCOP can provide valid arrangement of the supply chain, a valid arrangement of intrafactory operations, and also we can look into providing optimal solutions for such arrangements. And to conclude, the data required for the SCOP implementation are the same as for the SDT implementation. Thank you all.
We have answered most of the questions. If some are not answered, please tell us. Or you can ask more if you have, or you can send us by email. The email and contacts are provided in the chat. I think we can close. We will publish the webinar and the presentations on our website, and we invite you to ask questions till we can answer to you, and we wish you good luck.